Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod.
In last session, we have seen the basics of mechanical translation system and the variables describing that particular system along with the characterizing elements. Now, before going in detail with solving a problem about this particular mechanical translation system, we are supposed to know the formulas regarding this Laplace transform. So, Laplace transform of x of t is equal to x of s. Laplace transform of d by dt of x of t equal to s into x of s. Laplace transform of d square by dt square x of t equal to x square x of s here. Now, in this particular problem, as you can see, the initial input on this particular node is f of t here, force, where the output is x. So obviously on the whole of the system, the final output is in s domain, in Laplace domain is x of s, by the initial input f of s will give us the transfer function. Okay. Now by seeing this, obviously we do understand we do have two nodes, that is regarding mass m1 and m2, and because of two nodes available, we are supposed to get two differential equations and solving those two differential equations, and finally we get the transfer function frame in S domain. Now to start with, we'll start with the node m1 here. Now this is the representation of a free body diagram here. Here on this particular node m1, there is no direct input here. There is no direct input here, and that is obviously 0 here. But we do have opposing forces. The opposing forces are due to m1 mass, due to dashpot b1, due to elasticity or spring k1. In common we have another dashpot here and a spring here. Okay, so 1, 2, 3, 4 and this is 5. Now opposing force due to m1, opposing force due to b1, due to k1, due to b and k here. So you have 5 opposing elements here. Apply the condition, that is applied force equal to sum of opposing forces here. Anyhow here applied force is 0, will sum up the opposing forces here. The opposing forces are, as we can see from the free body diagram, that is Fm1 plus Fb1 plus Fk1 plus Fb plus Fk equal to 0. Clear? Now, as we all know from the previous concept that the opposing force due to mass is proportional to acceleration, that is m1 into d square x1 by dt square, plus the opposing force due to dashpot is proportional to velocity, that is given by b1 into dx1 by dt, plus due to spring, that is proportional to displacement, k1 x1, plus these are in common elements here. Now difference of the displacements. Okay, now this is proportional to same, just like this, b into d by dt, difference of the displacement x1 minus x, plus k into x1 minus x equal to 0. Now we have got this in t domain. Now we'll convert this into S domain, that is m1 s square x1 of s plus b1 x1 of s plus k1 x1 of s plus b into s into, here we are supposed to make it as b1 into s into x1 of s plus b into s into x1 of s minus x of s plus k into x1 of s minus x of s equal to 0. Now m1 s square x1 of s plus b1 s into x1 of s plus k1 x1 of s. You're multiplying this b into s into x1 of s minus b into s into x of s plus k into x1 of s minus k into x of s equal to 0. Now taking x1 of s common, now we get m1 s square plus b1 s plus k1 plus bs plus k. Okay, 1 2 3 4 5. Okay, and taking x of s common from the rest two terms here, minus x of s into b of s bs plus k equal to 0. Now the final frame we are supposed to get in terms of x of s. So you are supposed to write x1 of s in terms of x of s. So taking this whole to left hand side and getting the total frame in terms of x of s. So we get x1 of s equal to bs plus k by m1 s square plus s into b1 plus b plus k1 plus k whole into x of s. Now this is our first equation where we need this equation ahead. Now here we're supposed to write the differential equation for the node 2. Now the applied force is F of t here, where the opposing forces are due to m2, b2, and common we have b and k. 1, 2, 3, 4 are the opposing forces with respect to the input force being applied here. Let's draw the free body diagram. Now the free body diagram for node 2, that is mass m2. The displacement is x here, and the applied force is F of t here, and the opposing forces are due to Fm2, 1, Fb2, Fb, and Fk. Fk. Displacement, input force, opposing force due to m2, b2, k, and b. Now we'll apply the condition applied force equal to sum of opposing forces. Now here applied force F of t is equal to sum of opposing forces, that is Fm2 plus Fb2 plus Fb plus Fk. Now here F of t equal to m2 into proportional to acceleration d square x by dt square plus b2 into dx by dt plus b into, this is the common element, so x minus x1 here. Earlier it was x1 minus x with respect to node 1. Now with respect to node 2, so this is with respect to node 2 itself, it is x minus x1 plus k into x minus x1. Now this is in t domain. Let's convert it into s domain now. So f of s equal to m2 into s square into x of s plus b2 into s into x of s plus b into s into x of s minus x1 of s plus k into x of s minus x1 of s. Now here f of s equal to m2s square x of s plus b2 s into x of s. You're multiplying this x minus b x to x1 of s plus k into x of s minus k into x1 of s. Now f of x is equal to, taking x of s common, we have m2s square plus b2s plus bs plus k. Now taking x1 of s common, now that is x1 of s bs plus k. Okay, now this is equation 2 here. We are supposed to substitute this x1 of s, that is from the equation 1, substituting equation 1 in 2. Okay, so on the whole we get the total frame in terms of only x of s. So you are just trying to avoid this x1 of s by substituting x1 of s from the equation 1. That's equal to f of s. So already we have got this. Okay, this one. F of s is equal to m2s square b2s now x1 of s from the earlier equation 1, that is nothing but bs plus k we get. Now by substituting this x1 of s from equation 1 we get bs plus k square by m1 s square plus s into b1 plus b plus k1 plus k. Now finally from this total frame, by getting x of s, we are supposed to get x of s by f of s is equal to, taking the LCM and then getting this on one side, then we get m1 s square plus b1 plus b into s plus k1 plus k by m1 s square plus s into b1 plus b plus k1 plus k into m2 s square plus b2 plus b into s plus k minus bs plus k whole square. You do get this final frame. This is nothing but output by input. Okay, this is nothing but the transfer function for the particular mechanical translation system we have chosen. So while doing this in exam, so how do we represent the final output as? We are supposed to write the transfer function as well as we are supposed to write the individual differential equations also. Individual differential equations, that is, this is one differential equation regarding node M2 here. This is the second differential equation, and we have the first differential equation. This is the first differential equation. So we are supposed to write the transfer function along with the differential equation 1 and 2 for representing that particular system. Okay, this is how we represent the final result after solving this problem. That would be quite impressive. If you do have any queries, please comment in the comment section below. The next session we'll see few more problems along with the rotational systems also.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.